Needed a protector that was as powerful and as fast as the network it was trying to save. And this is the game changer. Our 10G PoE++ surge protector. Hi tech enthusiasts, welcome back to Fast Cabling. Now imagine this. You're part of a rural cooperative, and your mission is to bring high-speed internet to remote farm so they can use smart irrigation, monitor livestock cameras, and run their operations digitally. It's a great setup. High-power Wi-Fi access point mounted on barns using power over Ethernet through long cable. It works perfectly until the clouds roll in. Every time a thunderstorm passes by, the network goes down. Not just a glitch, hard down. You drive out to the farm, replace the access point or the switch port, and it works again until the next storm comes again. And this is the story of a real challenge we faced. Why do networks fail when it rains? And more importantly, how do you stop it from happening forever? So today in this video, I'm going to show you why that happened and reveal the industrial grade solution that finally brought peace to the farm. Now first thing first, the farmers thought the lightning was physically striking their equipment. But that's actually where. The real deal is something called a surge. When lightning hits the ground or an electrical line nearby, it creates a massive electromagnetic field. And that long Ethernet cable you run across the field, it acts like a giant antenna. It absorbs that energy. Now here's the vulnerability. In a PoE system, data and power travel together, and that makes the Ethernet cable a perfect superhighway for that surge energy to travel straight to an expensive switch or access point. But here's the part most people miss. Surge effects aren't always a big bang. Sometimes the surge is invisible. It causes data corruption, intermittent resets where the device just randomly reboots, and a shortened life cycle. So your device might be dying slowly and you wouldn't even know it. And we knew we have to stop that surge at the door. So our first attempt was logical. So we installed a standard PoE surge protector. We put it right where the cable enters the building. We grounded it. We felt pretty smart. But after the next storm, failure again. The network didn't just slow down, it became a bottleneck. So what happened? We ran into a classic tech trap: compatibility. Our new access point needed a lot of power. They were using the latest PoE standards, so the surge protector couldn't handle the higher power demand, and this created a data bottleneck, slowing down our farm cameras and a voltage mismatch, which actually choked the power delivery. So we needed a protector that was as powerful and as fast as the network it was trying to save. And this is the game changer. Our 10G PoE++ surge protector. And it looks like it means business because it does. Now let's break down why this little box solved our rural nightmare. First, the specs. It supports 10 gigabit per second data speeds. That means no bottleneck. The farm's data flows freely. Second, it handles up to 90 watts of power, supporting the latest PoE++ standard, IEEE 802.3 BT. So it powers the big radios without breaking a sweat. And see that metal clip on the back? That's the DIN rail mount. In an industrial rail setting, we're usually working with metal control cabinet, and this clicks right onto the standard rail inside. It's secure, grounded through the rack, and looks incredibly clean. And the compact designs mean it doesn't take up space we don't have. And it features a shielded RJ45 port to block interference and a heavy-duty grounding terminal to dump that deadly energy. Alright, so now let's mount them properly. And pay attention here, because this is where most people get it wrong. You always want the surge protector as close to the device as possible. So now let's mount it on the DIN rail nearby our switch. It's simple. Just mount it and click it. Now, on the surge protector, there's an in port. The in port means the surge is coming in from the outside, so we connect our outdoor cable to the in port. Just like this. And then we use a short patch cord here, connect from the out port directly to our expensive indoor switch. Let's plug it in. And here we have a short patch cord. Let's connect it to the router to get data. All right. Now, if a surge hit this line, it hits the protector first and get dumped to the ground before it even touched my switch. And now for the plot twist that I promised, a lot of people stop here. They protect the indoor side. But look at that long cable run. Where does the other end go? To an access point on a metal pole outside. That pole is a giant lightning. And this is a two-end protection. So we need a second surge protector right at the base of the access point. So here we already have a DIN rail. Again, let's mount it on the DIN rail. Just click. And there is one absolute rule here. Grounding. The protector needs a path to dump that energy. If there's no path, the surge will just jump over the protection and fry your gear anyway. So check your ground. Again, we use our outside long-run Ethernet cable, plug it into the input port, and then a short patch cord connect the output port to our access point so we can get clean energy here. Click and done. The whole setup is pretty simple. And by understanding that a surge is a two-way street, and by matching the protector speed and power to your network, we finally solved the mystery of the rain. Now, if you're running outdoor network, especially with power over Ethernet, don't wait for the invisible damage to pile up. Protect both ends. Use the right gear for the job. And don't let a little thunder ruin your uptime. Now, thank you very much for watching. The links to these surge protectors and the grounding supplies are in the description below. Don't forget to like and subscribe for more deep dives into network infrastructure. Thank you very much, and I'll see you in the next one.